Namaste, welcome back to Sthita Pragna, and you are watching AWS Cloud Projects, and we are in season 3, and in season 3 we are in project number 4, and the title of this project is Federated Queries. So what are we going to do in this project? In this project, what are we going to do? So basically City Hall has developed a ticketing system to manage citizen requests. Ticket notifications can include street damage, burned out street lights, and even noisy establishments. To plan better, City Hall now wants to use SQL to obtain more insights from these requests, such as the most common problem areas. So again, let's go ahead, dive into some SQL. How do we go into the projects? By clicking on this. And which project are we doing? Federated Queries or Route and Go. So that we don't have to, oh, she's right next to us, which is good. Hey, our pet. So let's click on her. Hello, thanks for coming by. I wanted to see if you could help with our effort to obtain business insights from data we have in Amazon Dynamodb. Hey, I would be glad to help. So what is the data and what kind of insights do you want to obtain? At City Hall, we created a ticketing system so that citizens can submit requests. Those tickets are stored in a Dynamodb table. We can quickly do basic queries from the database, but to get some real insights, we would like to run SQL queries against the data. Okay, I see the predicament. You can actually use SQL to query the data in a couple different ways. The first way uses an AWS glue function called a crawler to go through the data in your database and create an AWS glue data catalog out of it. That sounds really cool. Can we query the data catalog directly? No. You will need a couple of other steps. The next step is to use an extract, transform, and load job within AWS Glue. This ETL job takes the data as cataloged by the crawler and creates a data lake in S3. The job also transforms the data into one of several formats. I suggest a Parquet format for your purposes. And finally, after the data is in S3, you can do SQL queries with Amazon Athena against that data. Wow, that sounds like a lot of work, and it seems that we would need to do this over and over as the data changed in the database. You said there were a couple of ways to do this. Is the other way shorter? Yes, it is shorter. The good thing about the first option is that it creates the data lake in S3 for you, which you can use for other business intelligence. But it sounds like you want an efficient way to always query the most recent data. In that case, you can use what is called federated queries with Athena. With federated queries, you can run SQL queries against the data in Dynamodb through an AWS Lambda function that acts as an intermediary. That sounds much better. Is it hard to set up? Not at all. Great. Of course, maybe we want to try both ways, so we are familiar with them. Would you help us set up both methods for using SQL queries and data in Dynamodb? I would love to. So the learning objects for this project are, we are going to create and run AWS Glue crawler. Then we will move data to data lake in S3. Then we will use Athena to query the data, which we did in previous. And we are going to learn something called federated Athena queries with an AWS Lambda function. And the technologies that we are going to use and learn are Glue, Athena, and Dynamodb. Are you guys ready? So let's accept it. That is fantastic. This will be a great functionality addition. Let's start. As usual, we have our diagram. There are 7 steps, and the videos that if you want to learn to watch are these. Again, these are already available in our playlist called AWS Tutorials for Beginners with the same title. Alright, once you watch them, come back here and hit play. First step, the solution requires the ability to perform SQL queries on data that is stored in Amazon Dynamodb NoSQL database, which is what it is shown here. And in the first method, AWS, there are 2 methods, right? The first method, Glue reads the data from Dynamodb and creates an AWS Glue data catalog. This data catalog takes the form of an AWS Glue database and table. After the data catalog is in place, AWS Glue can run extract, transform, and ETL or load ETL job that uses the data in Dynamodb to create a data lake in an S3 bucket using the Parquet format. Athena can then use the data catalog and data lake to perform SQL queries on the data. Note that you will need to run the ETL job again because the data in DynamoDB changes. To avoid the required data lake refresh as the source data changes, federated queries can use SQL on the data source without the need for a data catalog or data lake. Federated queries use a connector function running on AWS Lambda to provide access to the data source. With the connector in place, Athena can perform SQL queries direct. Okay, so those are the two methods. Let's go on plan. Practice lab, what are we going to do? We are going to create and run AWS Glue crawler to create an AWS Glue data catalog from data housed in Amazon DynamoDB. Then we'll create and run AWS Glue ETL jobs to create data lake in S3 from the already created data catalog. Then we'll create and run query using Amazon Athena to obtain insights to the imported data. Then we'll create and run a query using Athena directly against the DynamoDB using federated query access. So if you are doing everything practice lab, what are we doing as part of DIY? We are going to create a copy of the DynamoDB ticket table by using the create table as command. Seriously? Then include an external location in a folder called new table. The DIY, it's okay. All right, let's start the lab. Let's see if there are any files. Yes, of course we have file. I think these files might be related to SQL queries, and yes, I can see them. Let's click on steps. There are 50 steps, but I think they will be small. We downloaded the file. We'll click on glue. You can read again. Then we'll go to crawlers, create a crawler, and the name we are going to give is ticket data crawler. Then is your data already mapped to glue tables? Not yet. Then we'll add the source, which will be DynamoDB, and the DynamoDB table name is that. Okay, let me copy paste these things so that I don't forget them. All right, then once we add that as the DynamoDB, then we'll click that source. Then the source will be created for our glue crawler. Then we'll click next. And then what are we? Obviously we have to choose a role, which is something they already created, which is AWS Glue Service Role Lab. Then click next. Then we are going to pick a target database, which is called Glue Ticket DB. And then scroll down, then we'll create the crawler. Okay. And once you create it, the state has to be ready. Once it is ready, we will run the crawler. So when you run, it is actually going to connect to the DynamoDB and then going to load the Glue DB. And preview run, and as you can see, it is completed. Looks like it won't take much time. And what is this? Click the tables to view that the tables are actually created. And then we will go and look at this table that is got created. Then we will go to ETL jobs, visual ETL, because we are going to create an ETL job right now that will store the data in data lake. And once you do that, we will, I think this is a stop. So let me go back. This is too much. Let me open the lab. All right. Where are we going? I already forgot where we are going. I think we have to go to glue. I don't see it here. Click on glue. Let's see how my memory works. Okay. We are here, but we have to go to glue crawler. Okay. I don't see it here. Do you guys see it here? Maybe it's somewhere here. Create a crawler, and the name, I have it here. Give that. Click next. Add data source. I think it is DynamoDB, and the table name, I have it right here. I think add the DynamoDB data source, then click next. IAM role they created for the lab. Click next. I think target database, this is the database we are going to use. So click next. I think pretty much that's it, done. Oh, this is ready already. Let's click run. And it is running, as you can see here. I think it will take about 30 seconds or so. So let it take its 30 seconds. Once it is done, we should have the table. But how will we see the table? We'll go and see it in the tables. Right now you don't see anything because that glue crawler is still running. Okay, it is completed. One table change. So let's go to the tables, refresh, and the table is here, right? I don't think they asked us to open this table. Okay, we have the table. I think that's good enough for us right now. So let's refresh, done. Now, since we have the table, now let's go to the ETL jobs, visual ETL, and we are going to create a glue job. Click on visual ETL. They want us to go to transforms, and I think that's about it, right? Then they want us to use glue data catalog. I think that is the source. So what do they want? Click on this and drop it, then click on transform. So we need to have the source first. So let me go there. Sources, click. Oh, it's already added. Transforms. Okay. Transforms, what do we want? Transform change schema. Okay, we'll click on it. Then it will come here. Okay. Then it wants targets. We are going to use S3. Okay, cool. Now we need to configure it. So let's go transforms change schema and then targets S3. Then I think we have to configure the change schema, I am assuming, or the first one itself we need to configure. Okay, database, I think it is this one. Job has not been saved. Table name, we have this one. Okay, it's configured successfully. And role, I think this one. I don't even have to look at that. Okay, let's go here. I think we picked that. We are good. Then S3 bucket, Parquet format, snappy, and then the browse. For the S3 bucket, I think we are going to choose the data lake bucket. So let's go here. Select that. No, Parquet, good, snappy, good, and browse, data lake, choose. Next, we are going to go to job. What is this? What do they want to scroll down? Then we have to still choose create a table in the data catalog, and on subsequent runs update the schema and add new partitions. Okay, where is it? Yeah, they want us to pick this one. Create a table in the data catalog. Yes, we want to. And on subsequent runs update the schema and new partitions. Yes. And the database, we already have it. Choose it. Table name, come on, are you not going to populate table name? Or we are going to create a table name, which is what, you didn't give the table name here or here. So we will type that, and then we'll click job details. We'll give the name ticket ETL job. Okay, that's fine. Job details, ticket ETL job. I think that should be good. And the role, we know what role to pick. And then we'll click on run. Then we'll go runs. Then we'll check the glue job. And it will be running. And then we'll go to S3 to view the data lake, if it got created or not. Well, they didn't tell us if you have to use this or something. I think we'll just use whatever the default ones that are actually mentioned here. I won't change anything. But what I will do, save it. And then we'll click run. I hope it was run. Then if you go to runs, it will be there. It will be running here. Okay, let's see how long it took for them to finish this. Does they show? It's just running. Did they say how long it will? Okay, go to the next step. We'll go to this 3. And the data lake bucket, okay, they are not even showing it. That's fine, but we'll copy it because we know why to copy it. Remember Athena project, guys? In the previous one, we have to give it the bucket where we want to store the results. I think for that reason they are using it. Oh, this is still running. That's fine. Let it run. We'll go and open another one. We'll go and do other things. And if I go, which is the data lake, Let me copy this. And we need to go to Athena. I think it will be under analytics. Yeah. I think we will get to use these in the next projects. I think again, try now. I think that's what they will show us anyways. Yeah, try now. Then AWS data catalog, ticket bucket, the glue ETL ticket table. Then manage, then we need to give that location. Oh no, they want us to give Athena bucket as the location. Okay. Then why the other bucket name copy? We'll see. Oh, I think we need to give that here in the copy paste. Okay, I got it. Because that is our data lake, so we are creating an external table on top of that, so makes sense. Is it still running? Yeah, it succeeded. Nice. So if I go to, yeah, I think it created the files, I guess, in my data lake. Snappy, Parquet, Snappy zip and Parquet format. Nice. Okay, so I'm here. It already selected that. So what am I supposed to do here? Yeah, just create this external table, I guess. I have the query right here. AWS provided it. So copy paste it. So we are creating another table called requests in the glue ticket DB, and the location we are pointing to is our data lake bucket location. I copy pasted this one. And what are we selecting? We are selecting everything that is in this particular table. Okay, so once I create it, another table should create it, and it should load all the data from this place into this particular table. So let me run it. And before doing that, it is not giving me all the running because we didn't choose the location where it has to store the results. And I think it is this. Once I choose this, now you will see it will give me the option to run. I think it was there. I just didn't see it, I guess. Anyways, it finished, and you should see another table called request, which we just created. Okay, so we have that now. If you want, you can read it here. Okay, next, go next. Let's go next. And then there is another query. What this query does is, let me explain here. Oh, where is it? Okay, let's copy paste it here. So if you are new to SQL, we are selecting request type and counting. You don't need that space. Okay, from request table, and we are grouping by and request type. So if we have 100 requests and if you have five request types, then it is going to give us results for those 5 groups, and then it will say how many records are there for each group. Okay, so basically group by is that, and then we are ordering by 2 means this is first and this is 2, so that's 2 descending order. So depending on the count, it is going to show from high to low. Got it? So if I run this query, that's what it will show. Okay, so the different groups and how many records that are there in this each group and descending order. Okay, so we did that. We clicked on that, pasted it, ran it, scrolled down, and we looked at the data. That's what we got. And then I think they might have asked us to run this to see if we are actually parsing the data properly or not. Then we'll click on data sources, and we'll create a data source, another data source. We already created glue. We will create another one, and which is Dynamodb. I think now we are going to learn how to do the federated queries. Once we click that, the data source name, we are going to give this. Let me copy this, paste it on my notepad. Okay, and then next, and we are going to use Athena connector function, which they already created it for us. Click next. I think create data source. Then we'll go to the query editor, and then we are going to use that new connection data source we used instead of the catalog. Then we are going to copy paste this SQL, and we will run it. And if you see, this SQL is similar to the other one, but using the federated query, and I think they will show us if the results are looking good or not. I think pretty much that's it. Wow. Federated query, don't you think it is straightforward? I don't know why they asked us to do glue and etc. But it makes sense. If you want to store your data in data lake, I think glue is the way to go. But if you just want to query, you have seen using the data federated queries is the way to go. Okay, once we have this, we are going to create what? A new data source. How did we create it? I think we went to data sources, create a data source, and we picked Dynamodb. Next, and the data source name is that. And then we have to pick the Lambda function, which is Athena connector. Next, and create data source. And once we have that, we'll go to query editor, and now we are going to pick that Dynamodb, and the table is already there that we created, but we are not going to use this to execute. Instead, we have to change the from, which is federated Dynamodb and default schema and that table. If I run it, it should show the same 7 records with the counts, respective counts. All right. Yes, it did show me 7 records with the respective counts, and hence that's the end of the practice lab. I learned federated queries. To be honest, I already used the glue visual ETL, so that is not new for me. And I also ran glue jobs previously, so that is not new for me either. But glue crawler, I have used that as well, so that is not new. But I think the only new thing that I learned from this is Dynamodb federated queries. Sorry, Athena federated queries. And I hope you learned something from this. So let's go and do our DIY, which is pretty straightforward if you ask me. All I have to do is create a copy of the Dynamodb ticket table by using the create table as command. And how are we going to do that? I will just tell you. But did they tell us to what name? Include an external location in a folder called new table in the data lake bucket S3. Okay, I think I'm going to reuse whatever we had. And I am going to go to where? Not here as well, here. Copy paste the old one, and they want me to create and I will just name this new table, it doesn't matter. And they want me to create it there, so and I will create the table name, same thing here, but they want me to use this one, so let me insert that, which I got it here, cut it, and I don't know if I have to create it here or there. Let me create it here itself. Athena Federated Dynamodb dot default dot new table, and this is going to be, what did we do wrong? Is it this? Maybe this needs to be put into quotes. I don't think so. Previously we didn't, but okay, let's put that. Let's run it. Okay. Unknown session property, you may need to manually clean the data at location. Athena will not delete data in your account. Invalid session property. Okay, maybe not in this. Should we create did they tell us where we need to create it? Ticket table, they told us to create it, but they didn't tell us where. Okay. Oh, they want us to glue ticket DB, never mind. That's where we'll create it then. Okay, got it. Never mind, that's why it might have thrown that error. Okay, let's run this. Even now it failed. Relate to path URI. Athena bucket before retrying. Athena will not delete data. Okay. Glue. Yeah. Okay. I thought it is easy, but it is. Oh, okay. Maybe this is the reason. Okay, let me go select this. Okay, that ran fine. So basically we are selecting from this and putting it into this table, which we created it in this database, and the location the data is going in is this one, which is what they asked us to do. So let's copy this one. Let's go here. Let's give it there, and I think it's called new table name. Validate. Is this our table name? I don't know. Is it? Maybe. If it's green, then yes. No, it is not. Which name did we create? New table. That's weird. Okay. I think that should work. Yep, it did work. So this is it's an okay DIY, but nevertheless we did something. All right. So this was fun. I mean, all the DIYs, only few of the DIYs are actually challenging. Most of them are like very easy, pretty straightforward. But at least this is fantastic. We didn't realize that Mr. Gorilla ran around that much. Help us. Okay, which one? I don't know. This is too much color. I think I'll pick this one. Yeah, it's okay. I guess okay project, but at least as I mentioned, I learned something new as well with this project. So I'm happy. I hope you learned something from it. Oh, too many fireworks. I think I leveled up. Yes, I did. And you know what it is now? It is time for feedback. If you haven't already subscribed, go ahead and do so. If you already subscribed, thank you very much. And don't forget to like, share, comment this video. That will really help this channel a lot. It will push it to other people, which means traffic will increase, which means it will help the channel. If you don't want to do that, you can support the channel by becoming a member and or by giving, I think, super chats and etc. So if you already did that, thank you very much. If you're not, this is the best time to do so that it will encourage me to do more videos. Now it's time for our zone zapping. No. Let's go. Which service helps users codify their infrastructure and treat their infrastructure as code? I don't know why they are asking this question. Obviously CloudFormation. But why are they asking about CloudFormation? This is cheating. They're not asking us questions regarding that at all. Okay, let's wait for some time. I don't think it supports 7-zip. At least that's my assumption. And my assumption is right. Volumes in EBS are automatically replicated within an availability zone. I think it is true. Let's check. Let's get a hint. Yeah, it is. It's been a while that we did something related to EBS. Let's do this. If it doesn't ask anything related to whatever we did, I think I will maybe zap a orange one, and then I think we can call it a day. Which types of auto scaling are valid? I think it's scheduled, dynamic, and predictive. These are instance types. Okay, so let's zap an orange one, and I think after that we can call it a day, because I don't see it asking me questions related to glue or Athena or anything like that. It's API. I hope I have the corresponding cards. Okay, I have all the cards. help your team decouple data processing and data ingestion to avoid resource congestion. Decoupling is always, usually we use SQS, and I think it is, yes, we have, and this is Lambda function and API gateway. And we already know API gateway is the entry point into our thing. So let's put it there. And then what are we going to have? Obviously, we are going to have SQS immediately after it, so that request, even if you get millions of requests, SQS will queue them so that you won't miss anything. Then one by one it will send to Lambda function. So that's like generic architecture. Let's see, where do we have SQS? Okay, here we go. And then we need Lambda. Okay, we have here. I think this should work. And it did indeed. Awesome. All right. I hope you enjoyed this project. If you did, you know what to do. That being said, have a wonderful day. See you in the next video. Peace out.